Okay, students, now we're going to review. We just reviewed synthesis reactions. This is still part of today's lesson. The second video for today, we're going to review decomposition reactions. Now, if you remember, before we left for the break, we actually heated up. We took copper sulfate, pentahydrate, and we added heat. And this was that pretty blue color. And it turned into a gray powder. This is a solid. This is called anhydrous copper sulfate, and it was gray or maybe white for some of you. And then we saw water coming off or out of the test tube as steam. I'm going to quickly balance this. This was a solid before. Now, you notice in this reaction, we started with one thing and we made more than one thing. So the general form of this reaction is AB yields A plus B. Okay, you could also have ABC yields A plus B plus C, or you could even have it yields AB plus C. You get the point. In other words, you're starting with one thing and you're turning it into two or more things. So this is called a decomposition reaction. And we did a decomposition reaction in class. And this one, if you remember, we actually went back and we added water, and then we reversed it, and we took our decomposition reaction, added water, and then it was a synthesis reaction again because we were back with our copper sulfate pentahydrate. Then the third type of reaction that we studied before the break was the fun dating reaction called a single replacement reaction. Now I know this pen clicks on here. I'm going to get a better microphone so you don't have to deal with that. But for now, we'll learn how to do this online learning thing together. Okay, anyway, a single replacement reaction, remember, person A goes to the movies alone, looks over, sees person B and C sitting together. A's like, well, I have more chemical energy than B, so I'm going to come over here and I'm going to trade places with you. Now B is alone singing all by myself, and then A combines with C. C had a very interesting evening because C arrived with one date and left with another, but I guess they say all's fair in love and war and chemistry, and that is a single replacement reaction. Now, on the last day of school, before you left for your break, we did a series of single replacement reactions. Well, the most fun one we did, remember we took copper and we put it in some silver nitrate. Now, remember I showed you the activity series, and if a metal is going to replace another metal, that's one way, or a non-metal can replace a non-metal, or a metal can replace hydrogen. But remember, regardless, you're given the activity series tells you that the element that's alone needs to be above the element that it's replacing. So when you look on an activity series chart, copper is well above silver. That's why we wear silver, because it's very not reactive. And gold and platinum, they're the lowest on the activity series. And anyway, copper can trade places with silver, and then we literally saw silver forming in our little 12-well plate, and we're not going to balance this or anything, and we made copper nitrate. Okay, so that was a single replacement reaction. Another single replacement reaction we did was a series of single replacement reactions. Remember, we had the blue liquid that everyone always wants to refer to as blue Gatorade, copper sulfate. And we had the copper sulfate, AQ, it's an aqueous solution. And then we had a series of metals. We put in tin, we put in zinc, we put in magnesium. Magnesium gave us a really, probably our best reaction. Why? Because magnesium is higher on the activity series, so these two guys can trade places super duper easy, and so now you have copper forming, and this guy is balanced with magnesium sulfate. So that's where we finished out, and we had a whole lab. If you look back, We did the whole lab. Let's see. And let's see if I can find our lab there. We were balancing reactions. And these were all the reactions that we did on that last day of school. And then we wrote our reactions down. We compared our predictions. Now, if you read the activity series correctly, your prediction and what you actually saw was perfect. It was, you got 6 out of 6 on your predictions. And of course, copper reaction 6 did not occur because copper can't replace itself in copper sulfate. I mean, why would you do that? You made a conclusion based on your predictions versus your observation, and your observations versus your actual activity series. And then we all came to the conclusion that we do think the activity series is an accurate predictor of reactivity. So that's where we were right before we left for break. So today what I'm going to teach you is a double replacement reaction.